Ladies and gentlemen, this is a video explaining the practice final. Almost identical to the actual final. Very similar to it. Let's jump right in. Question number 1. What is the solution to this system? You can't even see the system besides the graphs. And of course, what is a solution? First of all, when you look at an equation, that equation, when you look at that line, it represents all the infinite answers that exist to that equation. That's why there's an arrow going up forever and down forever. So this line actually represents an infinite amount of answers. So does this one. And if you're looking for that single answer that works for both, it's obviously that point of intersection, which is a coordinate 1, 2, 3, 1, 2. So 3, 2 is the correct answer. That is it. Let's move on to question number 2. Number 2, we're going to solve this system. I hope we remember how to solve systems. There are different ways of doing it. One, you could graph it and then find the point of intersection, kind of like we just talked about. Another is linear combinations. So linear combinations, or the elimination method, the goal is to get a variable to eliminate, either the x's or the y's. You need to determine which one you want to get rid of. So I would rather deal with the number 1 and 2 as opposed to 4 and 8. And the question is, how could this positive 2y eliminate with this? The only way the positive 2y is going to eliminate is if this is a negative 2y. And this is why we manipulate or modify that bottom equation by multiplying everything by negative 2. So the top equation is going to stay the same. And the bottom equation is going to change by multiplying everything by negative 2. So now we have the system ready to combine and eliminate. So let's do exactly that. The 4 and the negative 16, that'll give us a negative 12x. The positive 2y and the negative 2y completely eliminate. When we combine positive 14 with negative 50, that becomes negative 36. So what we have here is this blue equation, negative 12x equals negative 36. And that allows us to get rid of the multiplication of negative 12 right in front of it by dividing by negative 12. That'll eliminate. What you do to one side, you must do to the other. Divide by negative 12. And your final answer is right here. X equals negative 3. No, positive 3, I'm sorry. A negative divided by a negative is a positive. So ladies and gentlemen, that is the answer X. The question is it just X? No, look at our answer choices. They are ordered pairs. So just based on that one single answer, x equals 3, this one has the x value of negative 1. Remember, ordered pairs are x values and y values. This x value is positive 1, this x value is negative 3. The only one that has the x value being positive 3 is this one. So we already know that this is our answer. However, it's good to know if you have one answer and you want to find the other, you plug it into any equation you want. I'm going to plug it into the bottom equation. Let me rewrite the bottom equation. And you might be wondering, why did he put parentheses instead of the x? Well, I put parentheses instead of x because we're going to plug in the actual x value of 3 right in there. So we have 8 times 3, that's 24, plus y equals 25. And of course, to solve for y, you get rid of the 24 by subtracting 24, and you will get y equals positive 1. So your coordinate is the x value of 3, the y value of positive 1. 3, positive 1. So yes, this is our answer, but we already knew that. Let's move on to the next question, number 3. This question, it does say solve using the elimination method. Now, you could solve the system however you want. You could graph both equations, find the point of intersection. If you happen to see that they cross at the location 9, negative 3, then this would be your answer. You could also solve with elimination method, which is definitely what I would do. Combining the lines, it would give you a 5x. This would cancel out, and then you'd be able to solve for x. Or you could use substitution method. So whatever method you want. Right here, they're suggesting for you to use elimination method, which is a good idea. Why? Because the y values are already ready to combine and eliminate. So I don't have to modify any equations like I did previously on previous questions. Right here, just combine them. 4 plus 1 is 5, and we're talking about x's. The negative y and the positive y eliminate, equals 12 plus 33, that is 45. So I have this red equation, 5x equals 45. You're going to divide both sides by 5, right? And you will get the answer, if you divide by 5 here, divide by 5 there, you will get the answer x equals 9. So that is one answer. And once again, on this multiple choice test, if you notice that 9 is the only positive, the x value, man, I can't even speak right now, sorry. If you notice that all of your answers, the ordered pairs, the only one that has a positive 9 for x, that's not that one, is this one, right? This one doesn't have positive 9, that one doesn't have positive 9. So this must be your answer. But just to thoroughly explain how to get the complete answer, once you have the x value, plug it back into any equation you want and find your y value. So I want to go with the top equation. The top equation says x minus y equals 12. And I write it as parenthesis minus y equals 12. And why do I put a parenthesis? Because I know that x really is 9, so I'm going to plug in a 9 right there. And that's really a 9 take away y equals 12. 9 take away y equals 12. Let's get rid of the 9 by subtracting 9, subtracting 9. That eliminates. We end up with negative y equaling positive 3, which finally means that if you multiply both sides by negative 1, y equals negative 3. So there's your y value. And of course, there's your answer. The x value was 9, the y value was negative 3. That is our answer, but we already knew that just by finding the x value. Let's continue on to the next question. Question 4, again, use the elimination method to solve this system. And again, that's a great suggestion because it is ready to combine the lines and cancel out the x's to eliminate the x's. So let's do exactly that. Let's combine these guys. The 2 take away 2 eliminates. We have a 5 take away 1, that's a 4 with the y. Bring down the equal sign. 6 take away 6 also eliminates. That means 0. 6 take away 6 is 0. Now, a lot of students freak out right here and say, oh, no solution. No, the number 0 is an actual number. Continue solving, get y by itself. You divide by 4, divide by 4. 0 divided by any number is still 0. So we know that our y value will be 0. As you can see, it cannot be this answer because this answer has the y value of negative 3, and we know it has to be 0. Instead of checking the answers, I'm going to continue forth and plug in y equals 0 to any equation I want. I'm going to pick the top equation, so I'm going to rewrite it. 2x plus 5y equals 6. All I did was rewrite this top equation, and I am plugging in y into the parentheses in place of y. That's why I put parentheses instead of y, because I'm plugging in a 0. And of course, multiplying by 0 is ridiculously awesome. 5 times 0 is nothing. You could just scratch it out. You really have the equation 2x equals 6. And you could get rid of that multiplication of 2 by dividing both sides by 2, giving you your final answer, x equals 3. So you know your x, you know your y. The coordinate will be 3, 0. So which option has 3, 0? This bad boy right here. All right, let's move on to question number 5. Right here, they're suggesting for you to solve this system using substitution, okay? So what is substitution? I mean, you don't have to use substitution, okay? As a matter of fact, you could technically graph this and graph that, but I wouldn't recommend it because of such a high y-intercept value. You could graph it technically on Desmos and then see where they eliminate, or where they would cross, and that would be your answer. But let's use substitution the way they're asking us to. So what do they mean to use substitution? Well, first you got to make sure that a letter is by itself, as in x equals or y equals, and that is the case. We do have y equaling 6x minus 34. That's what y equals. Okay, so let's look at the other equation. Where's y at? See, since I know that y equals this, I'm going to plug this into wherever y is at, and y happens to be on the left side of this equal sign. Right? So like if I said y equals 5, you'd plug in a 5 right there, and then you'd solve. If it said y equals x, you'd plug in an x right there, and then you would solve this equation. But you have y equals 6x minus 34. Yes, that is a 6x. I got weirded out right there for a bit. So let's plug in the 6x minus 34 into that y position. All right, so instead of y, it's going to say 6x minus 34. It does say equals negative 3x plus 11. Now, the parentheses are really not necessary. I just like to plug them in parentheses just in case there's something else out here that I need to distribute. There is nothing to distribute, so I really do not need those parentheses. I'm going to erase them now. So this is our equation. Let's solve it. Let's get x by itself on one side. I'm going to add 3x. Add 3x. I will have 9x minus 34 equaling 11. Let's continue solving. Let's get rid of the 34 by adding 34 and adding 34. That will give us 9x equaling 45. Final step is to get rid of the multiplication of 9 by dividing by 9, and we have our final answer here, x equals 5. So we have our x value, we still need our y value. We're going to take this x value of 5 and plug it into any equation I want into the x position because it says x equals 5. So let's take that 5 and plug it into x right on that top equation. I'm going to rewrite the top equation up here. Y equals -3, but instead of x, I'm putting parentheses, plus 11. Now, why did I put parentheses? Because I'm going to plug in this x value of 5 right in there. So what do I really have? I have y equals -15 because -3 times 5 is -15 plus 11, which means y equals -4. So your y value is -4. So these are your two values. X is 5, y is -4. As an ordered pair, that'll be +5 and -4. This is your answer. Okay, let's move on to question number 6. This one's pretty straight up. It says, which of the following equations matches a standard form of a quadratic? All right, I hope we remember standard form quadratics are ax squared plus bx plus c, right? And it doesn't, I mean, your a value could be 1, which means that there's no number right there. But you do have an x squared term, then you have a regular x term with maybe a number in front of it with a regular number, or maybe 0. There is no number out there. But this is a standard form quadratic trinomial. What other forms do we know? We also know vertex form when we were graphing parabolas, and that was y equals a parentheses x minus h close parentheses squared plus k. Again, this one was standard form. So the question is, which of these following are in standard form? This is not standard form. It doesn't have a x squared plus something x right here. This is standard form. This is a standard form quadratic trinomial where your a value is 1, your b value is 5, and your c value is 6. This is vertex form, and this is just y equals mx plus b. So this is the correct answer. Let's move on to question number 7. Find the zeros of the equation. Now remember, finding the zeros, finding the roots, finding the solutions, they all mean the same thing. All these phrases mean the same exact thing, right? Zeros, roots, x-intercepts, solutions, all just mean the answers, okay? So when they say find the zeros, you want to find the answers to this equation, and we should remember zero product property, which states that if you have something times something else and it equals 0, then the first something could be equal to 0, or the second something could be equal to 0. And if you solve both of those, obviously you'll get x equals -4, and plus 7, you'd get x equals +7. So you have your two answers, -4 and 7. As you could see, that is the correct option right there, -4 and 7. Moving on, find the axis of symmetry equation. This is a quadratic trinomial. This is a parabola, and we know that the axis of symmetry equation is the equation x equals the x value of your vertex. However, we don't see the vertex right here. It would be awesome if this were in vertex form. You could clearly see the h and the k, but this is non-vertex form. It's in standard form. So we must remember the formula for vertex. Okay, the formula for vertex is x equals -b over 2 times a. And when we use this, we need to identify that a is 1, that b is -6, and that c is 11. C is not even in the equation. But let's identify a as 1 and b is -6, and let's plug it into our formula. X equals, now notice this, instead of -b over 2 times a, I put negative parenthesis over 2 times parenthesis. That way you could easily plug in the -6 right in there and the +1 right down there. When you simplify, a negative and a negative becomes a positive. 2 times 1 is 2. So you really have 6 divided by 2. So the x value of your vertex is 3. This is the x value of your vertex. If you were finding the vertex, if they ask you for the vertex, this would be the x value, that is 3. Now you could continue and plug in the 3 into the x and into the x and do the math, and you'll find the y value of your vertex. But they're not asking for the vertex, they're asking for the axis of symmetry, and we know that the axis of symmetry is really x equals the x value of your vertex, which we know is 3. So we already have enough information to answer the question, x equals 3. And it's always going to be an x equals because that's how you get a vertical line, and all of these parabolas either open up or down, so you need that axis of symmetry to be x equals the x value of your vertex. Let's move on. Same question. Let's do it the same way. Let's find the x value of our vertex by using negative b over 2 times a. That'll be negative parenthesis over 2 times parenthesis. The b value is negative 8. The a value is 2. So what we really have here is a positive 8 over 2 times 2 is 4, which really means that x equals 2. Now that is the vertex x value. If you want the y value, take that x value of 2 and plug it in right there and square it, then multiply. Plug in the 2 right there, multiply, and then subtract the two numbers and add 11, and you'll have your y value of your vertex. But they're not asking for the vertex, they're asking for the axis of symmetry, which we know is x equals the x value of your vertex. So we have it right there. Moving on to question number 10. Factor. We do have a quadratic trinomial right here, and the a value is 1. There's no number that we see out here. So whenever you see that, go ahead and start this factored form format with whatever variable you have right there. It's k squared, so you know it's going to be a k times k. Now the trick to filling in these spots right here is to think what times what is the c value that if you combine together is the b value. And you may have to make a list, right? How are you going to get c? Well, 1 times 12, that'll give you 12. 2 times 6, 3 times 4, 4 times 3, it's already there. So those are the only 3 possible ways of getting the answer 12 when you're multiplying, besides changing the signs to be a negative times a negative. But anyway, again, the idea is which of these pair of numbers combines together to give you that middle value 7. Okay, 12 plus 1 is 13, that's not 7. 6 plus 2 is 8, that's not 7. 3 plus 4 is 7. And if I add 3 plus 4, it's a positive 7, and b is a positive 7. So I don't need to change anything. I just need to put a positive 3 right here, positive 4 right there, and guess what? I am done. There's my answer. I have factored. Moving on to question number 11. Some more factoring. I love it. Parenthesis, 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 n. Those look like h's. What's going on here? Let's do an n and an n. How's that? Okay. Now let's think, what times what is the c value that if you combine together is the b value? Once again, make a list if you're struggling. Just start out with 1. 1 times 24. 2 times something is 24. And if you're struggling, get a calculator and divide 24 by 2, and that'll be 12. Try 3. 24 divided by 3 is 8. Try 4. 24 divided by 6 is 4. So that's how you could get your list. Now, obviously, 5 won't work. And if you go 6, you're already back to 6 times 4. So which pair of numbers combines together to give us the b value, positive 11? Well, 1 plus 24 is 25. Can't be that one. 12 plus 2 is 14. Can't be that one. 8 plus 3, that is 11. This is the winner right there. So plug in the 3 right there and the 8 right there, and you are good to go. Plus 3, positive 8. And the answer is right here. Moving on. Question number 12. Once again, a quadratic trinomial that they're asking us to factor. We have some k's right there. And we need to think what times what is the c value, negative 20, that if I combine together is the b value, positive 1. Okay, so what times what is negative 20? If you need to make a list, go for it. Negative 1 times 20. Negative 2 times 10. Negative 3 doesn't work. Negative 4 times 5. Those are all the possible ways of multiplying numbers together to get negative 20. And besides changing the signs, right? So let's actually combine and see which pair of numbers gives us that middle value of positive 1. 20 minus 1 is 19, not the b value, positive 1. 10 minus 12 is 8, not the b value, positive 1. Negative 4 plus 5, that does give us the b value, positive 1. So that's the pair of numbers that we want, the minus 4, the positive 5. By the way, it doesn't have to be a minus 4 first and a plus 5 second. You could switch the order. It could be a plus 5 and a minus 4, as they actually have it switched like that, plus 5 and minus 4. There's your answer for number 12. Let's move on to number 13. Number 13, this is where it gets fun, and I'm going to take more time on this one for sure. Right here we have an a value of 2, a b value of 11, and a c value of 12. Now, you cannot jump right into thinking a, because a times a is not 2a squared. It's only a squared. So you might have a 2 here, you might have a 2 over here. So let's do it using the multi-step method that we taught you in class, all right? So let's begin by doing step 1, which is multiplying A times C, which is really 2 times 12. That gives us a 24. Hold on a second, I'm sorry, 24. Okay, step 2, think of the multiples of 24. Let me go with 1 times 24, 2 times 12, 3 times 8, 4 times 6. Which pair of numbers combines together to give us the middle value 11? Well, that will be 3 plus 8. That'll give us 11. So at this point, you have the option of changing your trinomial to a polynomial by rewriting the middle value 11a to become 3a plus 8a, and you'd have 4 terms, and then you could factor by grouping, or you could use that shortcut method that we learned in class where you simply, let me highlight what you're going to write, you simply write down this without the square in the factored form format. So let's jump right into the factored form format, and I'm going to write a 2a right there and a 2a right there. Again, this is incorrect right now. All you do is rewrite whatever you see here without the square, write it 2 times, right there as the first part of your first binomial, as the first part of your second binomial. Now after that, we use the pair of numbers that we got from step 2 and plug it into these empty spaces. So the 3 and the 8 go right here. So positive 3, positive 8. That is step 3. Now this is wrong, but we still need to do that 4th and final magical step of reducing the binomial, if possible. So 2 and 3. The reason why I say reduce is because you're not technically pulling out a GCF. It's technically not even a fraction. It's just dividing the binomial by whatever number you can. And since the first binomial, nothing could divide, you just rewrite it, 2a plus 3. The second binomial, there's a 2 and there's an 8. You could divide both of them by 2 and you'll get an a plus 4. Ladies and gentlemen, this right here is the factored form answer. Okay, if you don't believe me, if you wanted to double check, especially if you have some time, you could distribute 2a times a, get the 2a squared, 2a times 4, get 8a, 3a times 3 times a is 3a, 8a plus 3a is the 11a, and the 3 times 4 is 12. You could distribute and verify that it actually does produce this original question. So the answer is down here, 2a plus 3 times a plus 4. Moving on to question 14. That's another one, right? Same exact thing. The a value is not 1. The b value is negative 13 and the c value is negative 30. So the a value is not 1, which means you cannot jump right into x thinking what times what is 30, that if I combine together is negative 13. You cannot do that. Why not? Because this 3 messes it up. It might be a 3x right here. It might be a 3x over there. So we must use those multiple steps that we learned. So let's begin with multiplying a times c. Again, you always do this whenever you don't have an a value of 1. When you see a number in front of x squared, you must do this. And we go 3 times negative 30, we get a negative 90. Step 2 is to make a list of the multiples of negative 90, negative 1 times 90, negative 2 times 45. And if you don't know that, go ahead and divide 90 by 2, divide 90 by 3. And if you divide 90 by 3, you should get 30. Divide 90 by 4, which doesn't work. Divide 90 by 5. And notice I'm putting a negative in front of the first number. That gives us 18. And you could also start checking, right? And you could divide 90 by 6. You could divide 90 by 7, and it probably won't work, and so on, right? You get to negative 9 times 10. So you can divide all of those till you get all these possible ways of multiplying them together. Which pair of numbers combines together to give you the middle value, which is negative 13? So if you go 90 and 1, that's 89. That's not negative 13. You're going to keep going through all these numbers, and you're going to see that negative 5 and positive 18, when you multiply those together, it does give you that negative 30, but when you add them together, when you combine them, it'll give you a positive 13. And this is a negative 13. So it does give us the 13 that we need. The number is right, but the sign is wrong. That means that these numbers are right, but the signs are wrong. So change both of those signs. Make this a positive, make this a negative, and you're good to go. Now we can move on to step 3. So on the previous version, or on the previous question, I did say to plug in what you see right here without the square as the first part of your binomial on both of them, right? So we're going to plug in a 3x and a 3x, and we're going to take this pair of numbers from step 2 and plug them in also. So that'll be a plus 5 and a minus 18. And then step 4 is to magically divide the binomials by whatever you can. The first binomial, you can't do anything to it, so 3x plus 5. The second binomial, you could divide by 3. That'll give you a single x and a minus 6. And believe it or not, this is, whoops, sorry about that. This is your answer, okay, the factored form answer. And if you were doubting yourself, go ahead and distribute, and you should get the original question, 3x squared minus 13x minus 30. So there's your answer. And you know what, guys, if you're taking the final and you just blank out, I mean, this is ridiculous, but it's kind of like cheating. You could distribute x times 3x, x times negative 5, 6 times 3x, 6 times negative 5, and see if it gives you that answer. That's not the best way to do it. That could take way longer because you might not pick the right one till the very end, right? So anyway, which one is the correct answer here? This one right here. And I did want to show you the other way. I know there's the first original way that I showed you was same step 1, get the negative 90, same step 2, get the positive 5 and the negative 18. Now, the original way I showed you was factoring by grouping. So I would rewrite my quadratic trinomial, 3x squared, but instead of minus 13x, I'm going to write plus 5x and then minus 18x. Right? I just took those numbers, put x's on them, and that I really rewrote that middle term to these guys. If I add these guys together, it'll give me that negative 13x, and I still have the minus 30 at the very end. Now, this might be a waste of time because you don't have to do it this way. You could do it the shorter way that I just showed you. But I do want to at least review and tell you how you could actually use factoring by grouping. You see, I changed these 3 terms to become 4 terms, and now I could take a look at the first group right here, the first 2 terms, and look at the second group, and I could pull out a GCF from each group. So if I pull out the GCF of the first 2 numbers, it would simply be x. And in the second group, I could pull out the GCF, which would be negative 6. Okay, so if I do pull out an x from these 2, what do I have left on the inside? I have 3x plus 5. And if I pull out that negative 6 from these 2, well, negative 6 times what gets us a negative 18x? That would be a positive 3 with an x. And negative 6 times what gets us a negative 30? That would be a positive 5. Then you take a step back and recognize that you have a common binomial in the first group and in the second group. So you're going to pull out that common binomial out here in the front. Okay, this is factoring by grouping. Whoops. So let me write my binomial that I'm pulling out, the 3x plus 5. And what do I have left? Exaggerated parentheses, and this x comes down, and this minus 6 comes down, and there is your answer, 3x plus 5 times x minus 6. This is your answer. Same answer we got up here before, it just does take more time. But I wanted to explain both ways so you could take and pick whichever way you feel more comfortable with.